so this is 1.8 part 2, right? We did solving absolute value equations last week. Today we're going to do solving inequalities. Thursday we're going to start working on graphing. Thursday and Friday, and then we'll probably have a quiz next Monday. Just so you guys are aware of the next 2 sections. I haven't put anything on Canvas yet because I haven't talked to Ms. Glick, but we don't have to give you a week for quizzes, so just be aware that might happen. When we talk about absolute value inequalities, guys, I'm going to stress to you the and the or. The and the or is just a guide. It's not 100% going to be one way or the other, but it's a guide to kind of help you figure out what your solutions are to your inequalities. There's a specific way you have to do it in order to get your answers right, so make sure that you're paying attention to what we're doing here today. All right, if we're going to solve an inequality, read the inequality. What does it say? That says the absolute value of x minus 5, what? Less than 2. When I say less than, I want you guys to think of the word and, all right? If I have an and problem, I generally color in between the 2 points that I find. And since this is just a less than, I have open dots. Now, this is not going to be true 100% of the time, but a lot of times it is. So at the beginning, kind of identify that for yourself, and then you can figure out where you're going. Part of your answer is not going to be the graph with absolute value inequalities. It's just going to be your interval notation. So graphing is going to help you write your interval notation, but it's not going to be part of your answer. So the first thing we're going to do, just like we did when we were solving equations, you want to isolate the absolute value. Is my absolute value by itself? Guys, look up at the screen. Is absolute, okay. So I'm going to rewrite it 2 ways. I'm going to rewrite it exactly like it's written. X minus 5 less than 2. Pay attention to the second part. The second inequality, you flip the sign, the inequality sign, and you change the sign of the answer. So this becomes x minus 5 greater than negative 2. When you do this, you flip the inequality sign and you change the answer sign. Remember in our equations, we had positive 2, negative 2, whatever. We changed the sign of the answer. Here you have to flip the inequality sign as well. So now as we go through to solve, I'm going to add 5 to both sides. I get x is less than 7. And then I'm going to add 5 to both sides here. And I get x is greater than what? 3.
3.
All right. Now, your answer is going to be your interval notation. So I'm not asking you to graph it now, but you need to in order to make sure you know what your intervals look like. So just a quick picture. 3 would be here, 7 would be here. What are my dots look like? They're open. So if I said x is less than 7, I would shade this way, correct? And then if I said x was also greater than 3, I'd shade this way. Do you see right here where they overlap, where the colors overlap? That's your solution. So it would be from 3 to 7. And I'm using parentheses because it does not include the 3 or the 7. Now, I'd say 90% of the time, at the beginning, we recognized that this was an and we knew we were going to color before. So you can just go ahead and do that. But I'm going to show you some examples where when you multiply or divide by a negative number, if you rewrite your inequality sign, at the beginning you may identify that it's an and, but then it becomes an or vice versa. You'll see what I mean in a second here. So let's do number 2. I'm not going to do all of these, but let's do number 2. All right, first thing I'm going to do, is this an and or an or? Absolute value 2x is less than, so I'm going to say and. And when I have an and problem, my graph looks something like that. So first, identify, is your absolute value by itself?
Yes.
Yes. So I'm going to write 2x is less than or equal to 20. And I have 2x is greater than or equal to negative 20. You have to do both. Flip the sign of the inequality and flip the sign of the answer. So if I'm going to divide both sides by 2, I get x is less than or equal to 10. And here I divide by 2, and I get x is greater than or equal to negative 10. So a quick little picture. Negative 10 would be on this side, positive 10 would be on this side. I have a closed circle. So it says x is less than 10, so I go that way. X is greater than or equal to negative. So do you guys see where they overlap? You see the overlapping? Okay, so then that is my interval notation from negative 10 to positive 10. That's my solution set. And it's brackets because it's includes, right? Okay. So look at 3. It's a very similar problem. The only thing that's different is this is a what? Absolute value 2x is, what does that sign say?
Greater.
Greater. This is an or problem. So when I have an or, generally my picture looks like this and I go opposite directions. Right? I have open circles because there's no line underneath. You guys with me? All right, so I have 2x is greater than 7 or 2x is less than negative 7. We flip the inequality sign and change the sign of the number. Solve it. Divide both sides by 2. And I get x is greater than 7 over 2. Or divide both sides by 2. X is less than negative 7 over 2. Agreed? Yes or no?
Yes.
Okay, so let's just see what our interval notation should look like for our answer. Negative 7 over 2 would be here. Positive 7 over 2 here. We have open dots, we said. So the inequality on the left says x is greater than 7 over 2. So I go this way. The inequality on the right says x is less than. So look it. You guys can clearly see what your interval notation should be. Am I coloring in between or did I go the opposite direction? Opposite direction. So I start over here at negative infinity. This is positive over here. So my interval notation would be negative infinity to negative 7 over 2 union 7 over 2 to positive infinity. And that is what my answer would look like. Does anybody have any questions? So if I look at, let's say number 4. Number 4 is a what? Less than. So it's an and. And I'm going to color in between my closed dots because it says or equal to underneath. Is my absolute value completely by itself? Okay, so I can rewrite as x minus 4 less than or equal to 10, just exactly like you see it. And then x minus 4, flip the sign, so greater than or equal to, change the sign, negative 10. So go through the solving process just like we would if it was an equation. You're going to add 4 to both sides, so you get x is less than or equal to 14. Add 4 to both sides, and x is greater than or equal to negative 6. So a quick little picture. Negative 6 would be on the left-hand side, 14 would be on the right. I have closed dots. And read your inequalities. The one on the left says x is less than or equal to 14, so it goes that way. Negative 6, x is greater than or equal to, so where they overlap, their intersection is what our solution set is. So it would be bracket negative 6 to 14. Close your bracket. All right. All right, let's do number 7. Read it to me. Greater, so it's an or. When I have an or, I shade in opposite directions, and since my dot is colored in, since I have an underneath, the equal to sign underneath, I'm gonna color in my dots. Get your absolute value all by itself, it is. So 2x plus 1 greater than or equal to 3, or 2x plus 1 less than or equal to negative 3. Flip the inequality sign and change the sign on the answer. So when you go to solve this, guys, minus 1 from both sides. 2x is greater than or equal to 2. Divide by 2, and I get x is greater than or equal to 1. Minus 1 from both sides. 2x is less than or equal to negative 4. Divide by 2. X is less than or equal to negative 2. So my quick little picture. negative 2 and 1. I have closed dots at both. So I have x is greater than 1 or less than or equal to negative 2. So I'd have negative infinity, negative 2, union 1 to infinity. Questions? All right, let's look at 9. How's 9 a little bit different? Yep, perfect. You got to isolate. You have to isolate the absolute value. It has to be by itself. A lot of you made some mistakes on this, especially in the solving portion of the test. You have to undo addition, subtraction first, guys. Then you undo multiplication, division. So I'm going to first say that this is an and problem because it's less than. And I have open dots because there's no or equal to underneath my inequality. But the first thing I'm going to do is add 3 to both sides. So I have 4 times the absolute value of x plus 2 is less than 16. Divide by 4. So I have the absolute value of x plus 2 is less than 4. Now we can solve our inequality. I can write my 2 at inequalities as x plus 2 is less than 4. And x plus 2 is greater than negative 4. Subtract 2 from both sides. You get x is less than 2. Subtract 2 from both sides. You get x is greater than negative 6. So a quick little picture. Negative 6 would be on this side. 2 would be on this side. We have open dots at both. So my inequality on the left says x is less than 2. So I'd color that way. My inequality on the right says that x is greater than negative 6, so I color that way. So where they overlap, the colors overlap, is my intersection. So I would say negative 6 to 2, and it does not include. At any point you guys wanted to check, this is really easy to check. Pick a point that's inside your intersection or wherever you're telling me that the graphs, the inequalities work. And if you plug a point in, it should work. Anybody have any questions so far? All right, pay attention. Super close attention to number 10, please. Every single time we've started off and identified if we had an and or an or, it worked out exactly like we said it would by just looking at it. So this one says great or, right? And it's going to be closed dots because it says or equal to underneath. Now, when I go through this problem, like Nico just told us, we've got to get our absolute value by itself before we can break our inequalities into 2 different ones. So I'm going to subtract 8 from both sides. I get negative absolute value 2x minus 1 is greater than or equal to negative 2. Now what do? When I multiply or divide by a negative number, what happens to my inequality sign? It flips. It changes. You guys see that? If you forget to do that, your whole problem is going to be wrong. Because now that my absolute value is by itself, now we can split up into our 2 inequalities. I can say 2x minus 1 is less than or equal to 2. And I can say 2x minus 1 is greater than or equal to negative 2. Go through the solving. Add 1 to both sides. You get 2x is less than or equal to 3. Divide by 2. X is less than or equal to 3 over 2. Add 1 to both sides. 2x is greater than or equal to negative 1. Divide by 2. X is greater than or equal to negative 1/2. Now, at the very beginning, we told ourselves that this was an OR problem. In an OR problem, you color opposite directions. This is why I tell you it's important to identify, but then just make yourself a quick little picture just to make sure what your inequalities, what you solve for, see where the solution actually lies. We have closed dots at both of these points because it's or equal to. But this inequality on the left says x is less than or equal to 3 over 2, right? That's this way. The inequality on the right says x is greater than or equal to negative 1/2. So this is actually not an OR problem. It started off as one. But doing our calculations and isolating our absolute value as we went through, we ended up having to divide or multiply by a negative number. So our inequality sign switched. So our answer here would be negative 1/2 to positive 3/2 in brackets. Tiny little things make huge differences in these problems, guys. You got to really make sure that you're paying attention. All right, keep it moving. Keep it moving. What does this one start out as? This is an or. Greater than or equal to or just great or? Just greater. So that means I have open dots and I'm going to generally color the opposite direction. So let's isolate our absolute value. Got to get absolute value by itself. What am I going to do first? Do I divide by 7 or do I subtract 5? Okay, subtract 5. 7 times the absolute value of x plus 2 is greater than negative 1. Divide by 7, right? So absolute value of x plus 2 greater than negative 1/7. Pay attention to this one. Now that I have absolute value by itself, it's x plus 2 is greater than negative 1/7, and x plus 2 is less than positive 1/7. Every single answer that we have done so far, the number on the right-hand side of the inequality sign was positive, right? This one is now negative. Let's see if it makes a difference. You're going to have to work with fractions, guys. You're going to be okay. If I want to get x all by itself, I'm going to subtract 2. If I subtract the whole number 2, it's 2/1. If I want to change 2/1 to 7ths, would you guys agree with me this would become negative 14/2? Yes or no? 2/1, same as 14/2? Okay, so negative 1 and negative 14 is negative 15/2. Same thing here. I'm going to subtract 2 from both sides. When I subtract 2/1, this is the same as minus 14/2. So I get x is less than negative 13/2. Draw yourself a quick picture. Negative 15/2, negative 13/2. I have open circles. We originally said in our problem that this was a greater. Right? If I say that x is greater than negative 15/2, I go that way. And if I say x is less than negative 13/2, I go that way. So we originally said this was going to be a greater problem, and I was going to shade opposite directions. But since we got to this point right here, and my answer was negative, that means it's going to flip everything around. So don't go solely based on what you say in the beginning. 90% of the time that's going to be true, but sometimes when you're working through the problem and we multiply, divide, we flip things around, it becomes the opposite of what you originally thought. So this would be from negative 15/2 to negative 13/2. It does not include those two numbers, so we just have our parentheses. I'm looking at 14. Okay, originally we're going to say this is what kind of a problem. Is this a less than or is this a greater?
Less than.
Okay, so I'm going to say it's an and. Means I'm going to color in the middle, and I have my dots colored in because it's or equal to. Now I want to get my absolute value completely by itself. Is it by itself 100%? What's the problem? There's a 1 where? On top. This is a fraction. We don't want to start off with a fraction. We don't want to start off with our absolute value in the denominator. So in order to get rid of that 2x minus 3, the absolute value, what would I do? Okay, I'm going to multiply both sides of my inequality by the absolute value of 2x minus 3. So this cancels out. I have 1 is less than or equal to 5 times the absolute value of 2x minus 3. All right, still trying to get the absolute value by itself. So what can I do? I need absolute values to be all by itself. What can I do? Okay, good. Divide by 5. So I have 1/5 is less than or equal to the absolute value of 2x minus 3. All right, we don't like the way that that's written because x is on the right-hand side. So if I rewrite this with 2x minus 3 on the left-hand side, what happens to my inequality sign? It flips. Because if you read this, you would say 1/5 is less than or equal to 2x minus 3. Well, absolute value of 2x minus 3 is greater than or equal to 1/5 is the exact same thing. So now that we've isolated our absolute value, I'm going to say 2x minus 3 is greater than or equal to 1/5. And 2x minus 3 is less than or equal to negative 1/5. And again, guys, you're going to have fractions. That's going to happen. You're going to be fine. If I'm going to solve this, I would add 3 to both sides. So I have 2x is greater than or equal to. If I have the whole number 3, how many fifths is that? The whole number 3, how many fifths? Nico, Kyle, how many fifths? Yep, 15 over 3. So I'm going to rewrite this as 15 over 3. So if I have 1/5, I'm sorry, I don't know why I said that. I went to 5s, right? Yeah. If I have 1/5 plus 15 fifths, that gives me a total of 16 over 5. Same thing here. I'm going to add 3 to both sides. Again, you guys just told me that the whole number 3 is 15 fifths. So this is going to be less than or equal to 14 fifths, right? Divide by 2. Duque, pay attention to this. Sophia, pay attention to this. Guys, this says 16 over 5 divided by 2 over 1. How do you divide fractions? No. What's... Keep, change, flip. Good. So I have 16 over 5 times 1 over 2. Well, what happens with 16 and 2? They cancel. It becomes an 8. So your inequality now says x is greater than or equal to 8/5. You guys have to be able to do that. Have to. On the right-hand side, this says 14 fifths divided by 2 over 1. If I keep, change, flip, it's 14 fifths times 1 over 2. What happens to my 14 and my 2? Yep, we can simplify there. This becomes 7 over 5. So I have x is less than or equal to 7 fifths. Again, at the very beginning of this problem, we said that we had an and problem. That means in our mind we're going to say, okay, we got a color in between. Let's see what's going on. Give yourself a little mental picture because we had to do a lot of work here. We had to move stuff around, flip stuff over, all that stuff. So if I have greater than or equal to, that means I have solid dots at both of these points. My first inequality says x is greater than or equal to 8/5, yes? So I will go this way. My second inequality says x is less than or equal to 7/5, so I go this way. So what would my interval notation be for my answer for this problem? How would I write the green graph in interval notation? Start from left to right. What's over here? Okay, so negative infinity to what? 7/5, good. What's on 7/5? A bracket or a parenthesis? A bracket. And then how do I say in math, oh, there's a gap in the graph? Union, good. What? Bracket, good. 8/5 to infinity, good. All right, so that is the second part of absolute value equations and inequalities. Section 1.8 was solving equations, the first part, inequalities, the second part. Thursday, when I see you again, we're going to do 1.9, which is graphing. We're going to solve graphically a little differently than we're doing now. Then Friday, we're going to kind of do a little wrap up, get some extra practice. And then Monday, whatever that date is, 19th? Monday the 19th, you guys are going to have a quiz. I'll put it on Canvas in just a second, but you don't have to have a week's notice anyways.